Okay, hi. Currently I'm looking at Zunnurfiqri's work, and this is your recursive design approach. You're talking about motor nerves, you're talking about three types of nerves, autonomic nerves. You need to correct the spellings first. I think I've mentioned this one before, so make sure all your terms and your definitions are correct, because these are not the kind of things that you want to mess up. Okay, so looking at your second slide, in the second slide, I can understand on what you wanted to do. I'm looking at this zone 1, 2, 3, 4 and 5, so I get the kind of layout that you want to attempt. Although this part, the semantics, trying to understand the architecture part, this one can come a little bit later, because what we need to understand is the part about the layout and the structure. So let's look at how your translation into recursion can produce a good architectural design. So when I look at this, okay, I can see the potentials. You can get lots of different shapes. However, you are working on a very standard, very Cartesian coordinates. So you're gonna have limitations. This is just gonna be on x and y axis only, and all you do is just rotation. You don't have to do rotations at all. You don't have to do grids. You don't have to have mirroring or rotations or translations and all that kind of stuff. You just need to choose one, okay? And when you do, you have to justify why did you choose rotation in 90 degrees. You need to justify why this is 90 degrees in the first place. For example, here you have a combination of 90 degrees, 30 degrees and 150 degrees. Why? You need to justify this part. So when you get into the further down of your process, we have this standard grid. So we are looking at the shape using hexagon grid. So this one is quite typical, but the problem is it's too two-dimensional. Okay, so if you look at this is all in a flat plane. This is a two-dimensional grid. Okay, you are having problems trying to translate this into 3D. Even in your 3D form, you still have a very fixed, very limited grid that you work with. So my suggestion is to look at it in a different way. So here I have some example. So you have SketchUp. Okay, I've done some basic hexagonal grid. So this is a very 2D grid. Okay, everything is on the same plane, and let's say this one object, this represents this, so potential of the unit. So this can be anything. It can be any shape. It can be a circle, it can be it can be a sphere, it can be a cube, it can be anything. So whatever you want it to be. So your task is to actually put this on a grid. Okay, let's say you want to put it on that grid, and then you can make copies of it. Sometimes you can rescale and you can do other things. So you are mapping your units, okay, we call this design units, on a specific grid. And the problem is this grid is two-dimensional, so you need to figure this one out. So one example, my suggestion is for you to make it into a three-dimensional grid. For example, okay, sorry, let's delete this one. Let's take one piece. Okay, how do you turn this into a 3D grid? First of all, 3D grid does not mean this. Okay, and you just make another copy. This is still a two-dimensional grid. This is basically two layers of two-dimensional grids. You can do this, but what I want you to explore is a bit more complex. So I want you to look into this. So let's take this piece. Okay, so I want to make a copy. I want to rotate it 90 degrees, and I want to put it here. Okay, so this forms the basis of a two-dimensional grid, three-dimensional grid. This forms the basis of my three-dimensional grid. I'm going to rotate this 3 times. We need to draw a line here first. I'm going to rotate this. Okay, this is 60 degrees twice. So now you have this. Now you have new points here. So at first you have 6 points. 1, 2, 3, 4, 5, 6. This is basically points where you can put your object onto the hexagonal grid. Now I want to create a three-dimensional grid that we can have more points. So now we have 1, 2, 3, 4, 5, 6, the standard ones, and then we have the new ones. 1, 2, 3, 4, 5, and 6, and 7. So you have 7 new points where you can park this object. So you can put it here. Oops. Let's do that again. So you can put it here or here. So this is just the grid, because you're not going to watch, you're not going to use this grid anymore. So after that, you just delete it, and this is your basic form. Okay, there are many other things that you can do. So I've done a few here. Okay, this is another grid. That's another grid. So what do you do with it? You can copy this around, and you have a three-dimensional grid. Just using simple forms, simple shapes, just using simple shapes. So you can copy this on top of each other if you want, and all these points, all these intersection points are your grid. You can do anything with it, anything you want. Okay, you can identify, and you can just place this thing, this particular object there, and after you're done with it, these objects are the only thing that remains. Let's give it a color, maybe red, so that you can see it clearly. Okay, so these are the objects that you want to keep. The grids will be deleted. You don't need to see the grids. Okay, so you don't need to see that. All you need to see are the objects, the things that are remaining. You don't see this grid anymore. So unlike what you did here, the grid is pretty obvious. Okay, so I want you to try and explore and look at what you can do with these. Okay, so that's your three-dimensional grid. So you want to see this better. So this is just grid, this is your object. You want this, you don't need the grids. After you've done the grids, you can just delete the grids, and all you have is the object that you want to use. Okay, you can put it right there, or you can use the bottom part like this, and you can create different funny shapes, funny object. Okay, oops. Alright, so let's say these are your objects, so you can delete the grid, and you can start playing with, for example, scale. Just an example, you don't have to do this. If you want to do scale, justify it. If you want to move it about, justify it. If you want to do whatever you want, justify it. Okay, just a few examples. So once you have a very complex grid, then these objects can intersect each other. Sometimes they grow so big that they cross over together, and this will create some nice and interesting looking form. Alright, okay, so please explore more. Thank you.